হ্যালো, ম্যাডাম শুনতে পাচ্ছেন? হ্যালো?
হ্যাঁ, শুরু করে দাও।
হ্যাঁ, শুনতে পাচ্ছি।
ওকে। Good afternoon, everyone. On behalf of Department of Computer Science and Computer Application, Sarojini Naidu College for Women, Kolkata, I, Dr. Anindita Rai Choudhury, welcome you all to a national level webinar titled A Gentle Introduction to Machine Learning and Cloud Computing, organized by Department of Computer Science, Computer Application, and IQAC, Sarojini Naidu College for Women, Kolkata. We are living in the age of artificial intelligence. And knowingly or unknowingly, we are using machine learning in our daily life. Machine learning is everywhere. From showing relevant advertisement of your interest in Facebook, analyzing medical data for diagnosis, fraud detection in banking transaction, getting help of digital voice assistant like Alexa, which can follow your command for searching online information and even control lights of your smart home. Machine learning has changed our life by making it easier. At the same time, cloud computing is becoming our need day by day due to its potential to meet up huge demand of data storage as well as computing resources over internet. So the combination of machine learning and cloud computing is our present as well as future. Today's webinar is about these two important and relevant research areas of computer science. Now, I would like to invite our respected principal madam, Dr. Urmila Okil, to inaugurate the webinar and address our audience. Madam.
Thank you, Anindita. Good afternoon, everybody. Today, the Department of Computer Science, Computer Application, and IQAC of Sarojini Naidu College for Women have organized a one-day national level webinar on a gentle introduction to machine learning and cloud computing. On behalf of the college, I welcome all of you to this webinar. I express my deep gratitude to our Honorable President, Governing Body, Dr. Anjan Sinha, for giving the keynote address. I express my respect to the honorable speakers of today's webinar, Dr. Anabik Pal, Assistant Professor, Computer Science and Engineering, School of Engineering and Sciences, SRM University, Amaravati, and Dr. Deepashubhra Guhorai, Assistant Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Vellore, for giving us their valuable time. I thank all the participants to join in this webinar. Today's webinar is concentrated on two topics, namely machine learning and cloud computing. It's a few years now, people have been talking about machine learning as it promises a wide range of benefits that can affect every aspect of human life. Machine learning is a core form of artificial intelligence that enables machines to learn from past data and make predictions. Machine learning has helped us enhance not only many industrial and professional processes, but also our everyday living. Machine learning algorithms are now used extensively to solve various challenges ranging from traffic predictions to self-driving cars. A well-known example is Google Maps, which provides assistance in directions and traffic using machine learning algorithms. Another recent example is self-driving cars, which are soon become a part of our life. Machine learning is the core method that enables self-driving vehicles to visualize and predict the behavior of their surrounding objects. Considering its vast real-life applications, the first lecture of today's webinar introduces machine learning along with its applications. Designing a machine learning model for a real-world problem requires a lot of computational power, and most such models are built with a lot of data. However, everyone does not have access to strong machines. This is where cloud computing steps in. Cloud computing delivers computing resources such as IT infrastructure or data centers over the internet. This model allows businesses to rent storage space or access software programs from a cloud service provider instead of building and maintaining their own IT infrastructure or data center. Among other benefits, cloud computing offers easy scale up or scale down computational and storage needs. In effect, it can be used to model a real life problem in a cost effective way. However, there are certain risks associated with cloud computing. For example, security and data protection are major issues in cloud computing. Nevertheless, the cloud pay as you go model is useful for explosive artificial intelligence or machine learning workloads. Realizing its importance, the second lecture of today's webinar introduces cloud computing. On behalf of the college, I heartily welcome our respected speakers, and I strongly believe that today's webinar will be a grand success. I thank everyone for your participation. I thank the Department of Computer Science and Computer Application and all the IQAC team for organizing this webinar. Thank you all. Thank you once again. Namaskar.
Thank you, madam. Thank you very much for your informative welcome address. It's our privilege to hear keynote address from our respected president, governing body, Sarojini Naidu College for Women, Dr. Anjan Sinha. But due to his busy schedule, he is not able to join this webinar right now. But instead of his busy schedule, he has sent his recorded keynote address for us, for all the participants. So we'll be playing the recorded keynote address right now. Tomukno?
Discussion on machine learning and cloud computing is very appropriate when we stand at the brink of the fourth industrial revolution. This will be defined in the coming decade as technology infuses itself into every sphere of humanity, be it biological, social, environmental, or economic. The future lies in transcending the power of this technological revolution for betterment of humanity. Today, students are a different generation growing up in a constantly changing and troubled world. Technology is a dominant factor today. So is globalization. The fourth industrial revolution presents some of the most transformative opportunities in human history. Mankind has never before gone through such a revolutionary period. Such exponential rate of changes in terms of technologies and its uses in business and our personal lives presents massive opportunities. The whole concept of business, how we work and how we live, is changing. Unleashing the power of technologies at such a vast scale has the potential to transcend better and efficient ways of conducting business, working, and even living our daily lives. With opportunities come challenges. The first challenge is how do we use such transformative technologies? Education is the next revolution, and technology is changing the way we teach and learn. Infusing cutting edge technologies with new age curriculum is the future of education. Department of Computer Science and Computer Applications and IQAC of Sarojini Naidu College of Women deserves special appreciation for organizing this national level webinar.
Thank you, sir, for your informative keynote address. Now I would like to invite ex-coordinator of IQAC and Associate Professor of Bengali Department, Dr. Shantana Chakraborty, to say a few words regarding this web.
Thank you, Anindita. Good afternoon, everyone. Department of Computer Science, Computer Application and IQAC of Sarojini Naidu College for Women organizing a one-day national level webinar on A Gentle Introduction to Machine Learning and Cloud Computing on 28th May at 1 p.m. We are privileged to have with us today eminent speakers Dr. Anabik Pal, Assistant Professor, Computer Science and Engineering, School of Engineering and Sciences, SRM University, and Dr. Deep Shukla Guhurai, Assistant Professor, School of Computer Science and Engineering, Scope, Vellore. On behalf of IQAC, I extend my warm welcome to them and Dr. Anjan Sinha, Honorable President, Governing Body, Sarojini Naidu College for Women, and respected Principal Madam, Dr. Urmila Ukil, Joint Conveners, Dr. Anandarup Rai and Dr. Anindita Rai Choudhury, my colleagues, non-teaching staff, and our dear students and everyone attending the webinar. Machine learning is a modern innovation that has enhanced many industrial and professional processes as well as our daily lives. Machine learning can help us live happier, healthier, and more productive lives if we know how to apply its power. Use of machine learning in variety of application areas like intelligent gaming, automated transportation, enhanced healthcare, digital personal assistants, smart home, etc. are increasing day by day. One of the important applications of machine learning is self-driving car. Machine learning allows self-driving cars to instantly adapt to changing road conditions while at the same time learning from new road situations. Cloud computing is another research area of computer science, which is becoming popular day by day due to its capacity to handle huge amount of data generated from different application areas. Cloud computing is the delivery of computing services over the internet to offer faster innovation, flexible, and cost-efficient resources. Cloud computing enables client devices to access data and cloud applications over the internet from remote computers. So, I won't take too much of your time and directly pass on the mic to Anindita so that the session for today's afternoon can begin. Eagerly waiting to be enriched by the discussions today. Thank you.
Thank you, madam. It's my privilege to introduce our first speaker, Dr. Anabik Pal. Dr. Anabik Pal is working as an assistant professor in the Department of Computer Science and Engineering at SRM University, Andhra Pradesh. Before that, during December 2019 and December 2021, he was a postdoctoral fellow at the US National Library of Medicine, National Institute of Health, Maryland, USA. He received his doctoral degree from Indian Statistical Institute, Kolkata, West Bengal, India, in October 2019. Before the doctoral degree, he did Master of Engineering in Software Engineering and Master of Computer Application from Jadavpur University, Kolkata, West Bengal, in 2013 and 2011, respectively. He did BSc Computer Science Honours in 2008 from Ramakrishna Mission Residential College, Kolkata, West Bengal. His research interest includes machine learning, medical image analysis, computer vision, etc. His research works are available in different journals like Pattern Recognition, Computers in Biology and Medicine, IEEE Access, etc. And in several proceedings, he has published his publications. So without any further delay, I would like to invite our first speaker, Dr. Anabik Pal, to share his presentation.
Thanks for this nice introduction. So I'm sharing my screen. Good afternoon, everyone. So now I will talk about this a preliminary introduction. I will give a preliminary introductions on machine learning. So nowadays you are all aware that machine learning is a quite popular terminology. It has several business aspects, several problems, domains are there where it is used, and there is a huge demand for the machine learning engineers or machine learning scientists, etc., etc. So many things you are known. So here I will give some intuitive idea that what is inside it, but I will not consider, I am telling here that too much about mathematical things, rather give you some intuition about these topics. So, and my introduction is already given, so I am not repeating these things once more. So directly starting enter into my talk. So this talk can be done by interactive way. So anyone who is participating in these lectures may ask me if some things find interesting and want to listen from me or to be discussed a bit more. So for this seminar, I divide my lecture into 4 parts. First part, I will give an introduction to machine learning. And so, what is it? In the next part, I will discuss that what are the different types of machine learning which are widely used for several different application areas. The next step, I will discuss about how to design ML, that is machine learning based prediction systems. So what are the different components there and how to think to design those components, how to build a systems like that. And finally, I will discuss something about experimental design or evaluation of a machine learning models, how it can be done. Note that evaluation is important. So let's go into this topic. So you see that computer and computing systems are widely used for different purposes. So for long days when digital computer comes, it is used for many different type of solving problems. So they are mainly used for speed up computation or analysis. Suppose in a college they are producing their results. So some students want to see what marks he is getting. So if it is written in a notebook, he has to search one by one. But here a computer algorithm finds it at a glance and quickly he get it. Suppose someone wants to go from some places to different places. So some graph like algorithms are there. So how this destination can be reached through a path? What will be the shortest path? Those things can be done by computational approach, by faster way. Another thing is that if some numbers are given, data are given, you want to sort it. All those things are computational problems which are doing this computation and speed up it. Suppose you are interested to multiply two numbers or divide two numbers. So if you are going to manual, it will take time, but it will increase the speed if you are taking help from the computation. The thing is that here computational thing, what I am telling, that the problems which I was taking, that there is a algorithm. That means do this, then do this. If you find this, then do this, or do this, like conditional statement, looping, etc., etc. You can design these things to speed up your computation. And suppose some analysis, that is, if you are interested to get some assessment that who are the best student of this class, etc., etc., you can do it by speed up the computations. But there are many problems which are generally prediction problems. That things you cannot do by this computation, these kinds of computations. Why not? Because for those problems, prediction problems, there does not exist any algorithm. Algorithm means a specific algorithm that if you are go through these steps, you will get the correct results or get the results. It's never possible, like any prediction problems. So which I call that automatic decision making problem or decision supporting problems. So like what will be the temperature up 10 days later? What would be the price of the dollar 3 days later? So those are the prediction problems. Whether the checks X-ray, if you are putting to a computer, whether it has any kind of abnormality or not. Those are things which I am telling, those are mostly prediction problems. So for those problems, you do not have an algorithm. That is algorithm steps that you follow those steps and you can get the things. So the things, that computational task where you can speed up, so you can take the programmatic approach like C programming, Java programming, etc., etc. Those things are discussed in are part of the any BE or BSc level computer science courses or maybe electronics courses. There we are seeing that the algorithm which have the problem or which have an algorithm which can solve and find the correct results, they can be approached by a programmatic approach. They can be find out by programmatic approach. But the thing is that these automatic decision making problems, they cannot be done because for them no algorithm exists. So for that, these machine learning approaches are employed. Now, as a general block diagram, what I can say that in case of programmatic approaches, you have the data or input. You put it into an algorithm which is implemented into with a programming language, whatever it may be, and you are getting the output. So you know that what are the criteria for a algorithms and what it is and what it input and what would be the output. Those are done in this way. But in case of machine learning approach, what it is done? Machine learning, here machine comes from the computer science. Machine means algorithm. So you know that machine means kind of algorithm. Like we are saying that support vector machine, that is algorithm. So what it is that you have to build the algorithm, means what to do for predicting this. Do this step, then do this step. These things you have to find out first. That is the target of the machine learning. So what it is doing, that machine learning in a short phrase, it is saying that machine learning means learning from the data. So how learning from the data or learning from the previous experience? So what are the previous experience? That is a machine learning model takes input as well as what the expected output. And based on that, a prior experience, it is gathering and then analyze the prior experience and build an algorithm. That is how the decision can be taken. What will be the steps? That do these steps. If you find that, then do these things and check what it is. And gradually you predict something. So that's the basic difference between the programmatic approaches and the machine learning approaches. in programmatic approaches, algorithms is known, and for machine learning approaches, algorithm is not known. So we have to find out. Then we have to deal with the algorithm for prediction task. So now there are 4 types of machine learning algorithm. Supervised algorithm, that is some supervision is there. That is what I was telling. That what is my data and what is the output, the experience are available. Unsupervised, that is data is given, but the expected outputs are not available. So this is called unsupervised. No supervision is given. So only data are given. So I will give little deep discussion about the supervised and unsupervised algorithm in the later part of this talk. And another 2 are that semi-supervised. Here some data are labeled or some annotations are available, and some data are not, and majority of the data are not labeled. And another is that reinforcement data. Here it is in between, you can think that supervised and unsupervised. That means the levels are not static. So like gaming thing. If you move one step, then you can know that whether you are moving in the right track, how good your movement is. Like in chess playing, what you are doing. This is the reinforcement learning. So you don't know that whether it is a good move or not until your opponent, that is partner, is giving you the movement. So these are 4 different kinds of machine learning algorithms. So now in current scenario, machine learning is a huge topic, and in some university they are providing master degree on those topics. So there are lots of things are there, and I think that to dig this subject or into deeper, a candidate need have knowledge on the mathematics as well as programming, both things. So okay, those are the different things. I am not going to that, but while I will be talking, I will skip the mathematics and present the logical things here. So, what is supervised learning? Talk about some problems. Suppose automatic disease detection or severity assessment using clinical data. So disease detection means you know that several attempts has been taken. Suppose you are putting some digital image, that is the digital medical image, that is maybe radiology image or maybe microscopic image, etc., etc. From that, you have to detect whether the presence of a disease, or might be that severity assessment is in what stage the severity is there. In the cancer patient, in which stage this is there. So this is a supervised problem. Why? Because here you have the data as well as its level. Now, what is the level for this automatic disease detection? Whether there is presence of disease or not presence of disease. Another thing is that sorry. Hello? Okay. তাহলে একবার করবো দেখবে sorry, so I think that there is a problem that slides are not coming. So can you confirm whether this slides is coming or not?
Now it's showing, sir.
Okay. So sorry for that, actually I missed it, sorry. So supervised learning. So what I was talking, that automatic disease detection. Here the thing is that given a data, task is to predict whether a patient has disease or not. And either it may be that what kind of disease is there. These kinds of problems are also there. Severity assessment is in which level of severity the patient is suffering from. So this can be asked for a clinical data. Clinical data, it may be image, it may be ECG, it may be others information, etc., or maybe whatever it may be. So those are supervised learning. Another kind of problem is that automatic credit card fraud detection. So nowadays, many of us we are using this credit card. So some transactions are done by some fraud persons. So whether this is a fraudulent transaction or not, those kinds of things. So it may be fraud or non-fraud, what it is. So this is a kind of supervised learning algorithm. spam filtering in email. So here we see that in Gmail, some emails are coming directly to the inbox and some emails reached to the spam folder. So there is something that which is detecting the difference between these two, that whether some user or of this email will interested to this mail or not. So this is spam filtering. So recommending, that is, we are seeing that friends or groups on the Facebook recommendation comes that you may be interested to make this person in your friend list. You may be interested to be joined to these groups. In Facebook, we are looking. So this is a recommended systems. Another thing is that the several online selling sites like Amazon, Flipkart, Myntra, etc., they are suggesting books, movies, music, jokes, etc., etc. In different ways, jokes are not suggested by Amazon, Flipkart, but some several areas, these kinds of online things. So this is a recommendation system or recommending. So this is and another important problem is that language translation. Language translation means translating. We see that Google Translator. Here, if I putting some English text, this can be converted into Bengali or maybe into Hindi or different kind of things. Another is optical character recognition. That is a scanned document. Optical scanner when scan a handwritten document or maybe printed document, and from that you want to digitize them. So these are all supervised learning. Here you have to, for optical character recognition, you have to identify the character. For language translation, you have to convert from one sentence to another convert. Another is that weather forecasting. Weather forecasting means that what will be the temperature or whether there will be storm or not and what would be the humidity for a certain date. These kinds of problems are there. Another is that predicting the market value of a share. So everybody, where many people or many persons are interested to purchase the share or etc., etc. So there, whether the share value is increasing, so it will be beneficial. If 1 year later, if the market value is increasing for a particular share, so who will purchase the share will be benefited. So prediction of market value of a share is an important task. And predicting the price of a real estate, whether the price for this flat will be increased or decreased, and what it would be after 5 years or after 7 years. Those are all business strategic decision problems. So here I mention or introduce several supervised learning problems, applications which are considered we are facing many times. So only I mention only few, but there are lots of things. So if I am started talking about them, that it will take more than 1 hour. So it's not the thing. So the purpose here is that to explain here in a supervised learning what is your data and what is the supervision. So I think that those things are explained. So for the first problem, here is the data is the what image or maybe the some your diagnostic report or maybe the ECG report, etc., and the prediction is that whether there is disease or not, what is the disease severity level, etc. It may be credit card fraud, whether this is a fraud or not. For spam filtering, it is a spam filter, it is a spam or not, like that. So we see that there are two different kinds of problems are written here. For the first problems, which are colored with, I say, some red like colors, you see that there the prediction task is that yes, no, or kind of multiple choice like things. So kind of multiple choice things. Okay, disease severity is there? Yes, no. Severity level 0, 1, 2, 3. This is a fraud transaction? Yes, no. Spam filtering, this email is spam? Yes, no. Recommendation, so list of friends which can be recommended, like this. Language translation, what is the meaning of suppose say mango? Several words are there, what it is. Optical character, what is the word? Suppose some images are there, what is it? A, B, C, D, amongst 26 letters of English, what it is. So these are kind of multiple choice kind of answer, questions answers, prediction like that. So these are called classification problem. And another thing is that weather forecasting, predicting the market value, predicting the price of real estate, those kinds of problem, these are not like a multiple choice and question answering problem. These are need to have some real value or some floating value, I can say, real number or like that. So these are called regression problem. Now we are telling that several problems are there, supervised learning. It can take supervision from the past experience. Then how it can learn and build the model, prediction model or the algorithm for predicting something. These things I will be discussing. So the general framework is that data and levels are given. From that, it is passed to a learning algorithms and a prediction model is there. So what is data and what is level, I discussed in the earlier slides. And they are given to a machine learning algorithms and which builds a prediction model. So when this prediction model is developed, it's sent to the users for prediction. So then user put the unseen data or the data in the field where it is deployed, and from that, using this prediction model, the prediction is done, and based on that, decision can be taken based on how robust the model is. Now the thing is that types of supervised learning. So I mentioned that two different kinds of problems are there. One is regression and another is classification. What is the difference? I mentioned regression means predicting a suppose real valued number, and classification is a kind of multiple choice question answering things. Now regression analysis, what it is and why it is required. Suppose you want to predict the value of a real estate. So you have past experience. Okay, so you in a geometrical way, if I can present that, you can plot it into this kinds of 2D coordinate. So all black points are given that what is the value at that moment, 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 what is the value at that moment is given here, what is the value at that moment is given here. So now you have to predict the future. So it's what you have to do, you have to analyze the regression. That is, you have to fit a curve. So that there can be fitted this point. So what it is doing, that a straight line is fitted. So that the error is minimized. That means if this curve is showing that what its prediction would be, it will be some error based on this line. So in mathematical terms, you can write this line as a y equal to f of x. So here for one dimensional data it is shown. For one dimensional data means here x value is there, what is the y value is given. Here x is one dimensional. So a curve is plotted. So here curve means I am plotting a straight line. So that the points will be the error, that is the difference. That is according to this curve, if a point is your x value is that, so y value will be like that. So error is this to this, like that. So that error is minimized. In this way, some mathematical computation are done and a curve is fitted. Now, suppose one point, these points, what will be the value when the value of the x is here? I have to predict. So I will go this way and we find what is the value. That is the value in this line. While x is here, what is the value of y? That is be my prediction. So this prediction may or may not be true, and there are three different kinds of regression it would be. One is simple linear regression. Simple linear regression, that is one variable. So here your data is one dimensional. That is only x values are there and what would be my y values. That means you have a record for different year what is the value for a flat in a certain places. Okay, so only one value is there. Suppose this is in 1978, this is in 1988, like this way. So you want to predict that what was the value at that in this year. So value will be according to this analysis or this prediction model. The value will be what is the value here. That is the distance between this to this. So this is a simple linear regression. And multiple linear regression, that means your x will not be univariate. That is multiple factors will be there. So that may be that for real estate problems, it might be that what is the what is the who was who were running the government. It may be another factor that many kind of features it can be considered there. So, and what was the value of the dollar, etc., etc. Many kind of features you can consider. That is attribute, that is x. So x, when it is multivariate or multiple attribute it is considering, then we have to go for multiple linear regressions. And another is that polynomial regression. So here for a one-dimensional data we easily fit a straight line, but it may not be that this data may not be lying in this way. So there we need that to fit a polynomial that is of higher degree of x. That might also be possible. So here regression analysis, what is done in brief, that given some past experience, a line or maybe a curve is fitted with this point so that the error, that is deviation from this curve to the data points, are very less. Average distances, that is error, is less. In this principle, this things is done. So there are some mathematical calculations are there. I will not be going to there, but here I am giving some intuition about what is regression and how it is done. So now what I was talking about, that prediction may not be true. That means that time the price of the house, it might be like that in this one. So the error is that much. So here with machine learning, you are doing a regression analysis, you can predict a good scores, so that might have some error also. You have to consider it because you don't know that which curve fit this data well. So you have to assumption. So machine learnings, one thing is that while you are employing some algorithm, the important thing is that assumption about your data. That is also an important part. And that's all about regression analysis. So I am not going to the mathematical things details because this is a limited time talk. So now I am going to classification problems, and here I will discuss or introduce about different classification algorithms or approaches available in the literature. So first is decision tree. Decision tree means it looks like a tree. Here every node, that is internal node, takes a decision. Like here, suppose some data are given, they are analyzed, and then these trees are prepared. So what it is that if outlook, it might be sunny, overcast, or rain. So whether tennis will be played or not. So if outlook is overcast, then what other things are there, do not look at it. We'll play the tennis. If the weather is sunny, then check whether humidity or not. If it is humid, high, then don't play the tennis. If humidity is normal, then play. And raining, if wind is there and weak, then play. If wind is strong, then don't play the tennis. So this is a solution, I think, that of a problem taken from the Tom Mitchell's book. So whether a certain day there will be a tennis playing or not. So there were 14 data points or the 14 feature attributes set. That is 4 attributes, and there was 14 data. And based on that, if you are solving this decision tree, how it is solved, I am not going into this. You will get this kinds of tree. So looking at this trend tree, you can decision that someday whether there will be playing or not. So if you have information about outlook, humidity, and wind like that. So as these trees help to take decisions, so we are telling this as a decision tree. Another example is given that if the salary is in between $50,000 to $80,000, then and if the office is near to me, then it is checking that provides cab facility, then accept the offer, whether offer will be accepted or not, like that. So decision tree is a classifier. When it is trained, it gives a tree-like structures where every node takes decisions, and based on which, while you go to the leaf, the outcome, that is for a multiple choice questions, that what would be the answer, that is predicted. So here the two problems I chosen, that where the multiple choice questions, if I thinking like this way, that only 2 options are there. It may be more than 2. So as and here this I am saying, although I am saying that yes, no like things, but it might be more than 2 also. So this is a kind of classifier. So it comes after training from the data. And another thing may be that this is random forest. So the limitation of decision trees is that it may not represent the data well or like that. So the decision is taken from multiple trees which are constructed based on different set of features, or might be a subset or different subset of the available experiences, and combined decisions are taken in case of random forest. So because decision tree is too much biased with the data set, so to reduce the biasness or towards the data set, these random forests are used. So here multiple trees are trained, decision trees are trained, and prediction from the all trees are taken out and they are aggregated, and the class predictions are done. So both random forest decision trees, how it looks like is there. Both are statistical model. You need to have the data and you have to go for statistical and mathematical analysis, and after that you will get these kinds of prediction models. Now another important thing is that logistic regression. So logistic regression, so suppose you are dealing with a prediction model where your data is n-dimensional length. That means every data has a number of attributes. So what you are doing here, you are from this x1, x2, xn, you are defining a fx functions. So and after that it is transformed into y. And how you are getting this fx? The thing is that you have to multiply x1 into w1, x2 into w2, xn minus 1, wn minus 1, xn wn. That is here your x1, x2, xn. These are your data points given. This is the data point. That is x1 to xn is a data point for suppose data 1, and different values will be there x1, x2 for different data points. So the logistic regression, when it is trained, it finds out this set of w's, that is w1, w2, wn, and then produce with this multiplication, that w1 x1 plus w2 x2 plus wn minus 1 xn1, and compute the fx values. Then when this fx values is greater than a threshold, then it is saying that it is positive class or class 1, or if less than, it is saying that it is negative class or class 0. So in geometrical perspective, you can see that suppose your red data. So here I am talking about the multidimensional data, but for visual representation, here I am using two-dimensional data. This is y-axis and this is x-axis. So red class data are here and blue class data are here. So in geometrical perspective, the thing is that you have to draw a straight line, so which will separate these two data sets in a correct manner. So that all data, that correct manner means all data points on the red side will be on this side, and on the other side, in the other side of this line, all blue points will be there. So this mathematical model is doing that. The thing is that here the limitation here is that two limitation is that. First of all, so if you are doing this x1, w1, x2, w2, xn minus wn minus 1 like this way, if you are computing this f of x, so this separating hyperplane or the separating line will have to go through the center point. So it might not be the fact that suppose this is the data point and this is the data point. Here we are finding that this is the well separating than this one. Why? Because the distance from the closest point to here and this distance from the closest point to here are almost similar. Then this data set, this line is more close towards to this class. So this is the better classification line or the separating hyperplane or line, whatever you can say, multidimensional line or hyperplane. So how we can get, we can modify this model so that we get this yellow line. So for that, what it is doing, that one bias term is added. So it is assuming that features one single dimension has value 1 and it is multiplied by b. So B will have this value of the B will decide that how much it will be deviated from this 0, 0 point. And this will be your mathematical model. And another thing is that while you are taking that Fs greater than threshold, so this multiplication, that is this value, this F of value can be anything. That means minus, it can be minus infinity to infinity, it might be, I think. Minus infinity to infinity, it might be. But the thing is that how we will set the threshold. So can we project these values, infinite values, into a range from 0 to 1, so that it becomes a sigmoid transformation. That is, it is computing the exponential of this multiplication, that is 1b, x1, w1, x2, w2, x2, w3, x3. This terms exponential, negative exponential is taken, and 1 by 1 plus this is done. So what it will ensure that this value will be converted into 0 to 1 range. And if a data point lies on this point, its value, this functional value will be 0.5. And if the data point lies positive infinity in this side, it will be +1, and negative infinity in this side, it will be 0. So this is, in this way, this mathematical model is constructed. So one thing I must say or emphasize here, that here x1, x2 are the different attribute for a data, and w1, w2, b all are learned and represent the model, the logistic regression model, and they are obtained from the available training data or the available experiences. So that's why it is shown in the red color. And x1, x2 are the features which you are putting here. You can predict the model after if this model is trained. Now, multi-layer perceptron. So limitation here for this model is that if the data are linearly separable, that is a linear boundary can separate these two data sets, then only you can go for logistic regression. But data might not be that much easier, that linear boundary it might not have, so more complex it might be. So to capture the complex relationship or class separation between different class data, this multi-layer perception is done. So here what it is doing, that is W1, W2, WH and WH minus 1, WH, these weights matrices are learned. So that is learned means models are predicted, models are guessed, I can say that guessed from the available training experiences. Such that if we do this computation, WH transpose into WH minus 1 transpose into W2 transpose into W1 transpose X gives the prediction within the range 0, 1. And if this is positive, more than 0.5, then it will be class 1, and less than 0.5, it will be class 0. These kinds of things. But now the thing is that this is the goal, to decide these values or have these values. But the thing is that here we are saying that hidden layer, we are calling these internal layers as hidden layers, so which are represented by this way, WH minus 1, WH minus 2, W2, etc. etc. So the problem here is that looking at the who knows the mathematics or matrix multiplexer, etc., you see that although we are showing that some W transpose of something, here W's are different, but it can be collapsed into a single matrix, because that can be converted into a single matrix if we are doing so. So doing this or guessing one W is same. So that means this function cannot capture the nonlinear relationship. So some nonlinear relation has to employed into it. So one thing is that some activation, nonlinear activation is employed. Also we use the sigma function. That means when W and X W transpose X will be applied, this will be transformed into a nonlinear thing by nonlinear function. It may be sigma, it may be hyperbolic tangent. Some mathematical things are there, these things. So for multi-layer perceptron, these W's are guessed. So here model represents this W1, W2, WH minus 1, WH. So here all W's are also include this bias term also. Now support vector nations. So just a minute, sorry. So here what the previously I was telling about some mathematical model or complexion or something producing learning a model, and from that you are producing your prediction model. Now the thing is that support vector machine. Here what it is done, here among these all data points in the previously for those models, all data points are used to compute your W1, W2, this weight matrices, and for logistic regression also Ws are used. But for support vector machines, here some points are find out, that is who are near to the boundary. They are called support vectors. And based on these support vectors, the predictions for a new data point is done. So I am not going to details about this. So there are the difference between these two is that, so this is a kind of lazy learning. Like previously, suppose some students are reading some things and make some conception, and based on that they are going to exam hall and writing in the exams. So for support vector machine is that, so students are not reading a whole topic, they are choosing some important part and read them, and based on that they prepare. So important things they are reading only, and they go into the exam hall, and based on the things what they are reading, they answer in the problem. So what is the important thing or those things, that what is the most separating data point, that is who are in the boundary line. So those things are find out, that is which is given here. So then this boundaries you see are taken around, and the points, based on these points, when a new data point is coming, whether it is into positive class or negative class, that things is done. So I am not going into details about this mathematical model, but I am explaining only the intuition here. Another thing, so that here your decision boundary will be like that, but based on this decision boundary, this decision are not taken care of. The thing is that previously based on this decision line, this decision was taken, but for support vector machine, based on these data points, the decision was are taken. Now K nearest neighbor classifier. So this is a kind of classification algorithm that which looks the nearest neighbors, who are nearest to which classes data are nearest to a test data point. Suppose here some red class data are given and green class data are given, and a new data point is coming. So suppose you are going for one nearest neighbor. So from this blue data points, this green data class is closer. So if you are going to one ANN, then it will be considered as a green class data, because the nearest point, which is nearest, which is the data point which is nearest to this test data, belongs to green class. Suppose this data point is coming, so you are computing K nearest neighbors, computing among them who number of data points which are closer, which classes data are closer. Suppose from this data point, two green data points are closer, and then this one. So if you are going for 3NN, as two data points from the green class are closer, then the red class, only one is closer among these three data points. So if your K is 3, that is you are going for 3NN, you are choosing for 3 nearest neighbors, which will be like these 3 points. Among them, these 2 are from the green class, so these data points will be from the green class. And suppose one data point is there, so you are going for 3NN, so 3 data points all are belongs to red class. So these data points will be in the red class. So this is the K nearest neighbor classifier. The difference between other classifier is that in this classification, it is called lazy learning, because here no learning is there. That means all training data is copied, and every time training, based on the training data, this computation is done. So now this is another data point. So green class is closer, like that. So that is up to the supervised learning. So I hope that I give an intuitive idea about this classification and regression. Now I am going into this unsupervised learning. Unsupervised learning, I mentioned previously that no supervision is there. So why unsupervised learning? How it can be learned? What are the things can be learned? These are the things is to be discussed or coming into the mind. So the goal of unsupervised learning is to discover hidden and interesting patterns in the unlabeled data. Another is exploratory data analysis. Exploratory data analysis means suppose records several data are given. So when the sale was high, or in which time the sale was very poor, when time real estate value were increased, and from which side how much earning was done. These kinds of analysis can be done by this are called exploratory data analysis. That is understanding about the data. That is called exploratory data analysis. Another important thing is that unsupervised learning is that grouping or clustering. So you know that annotation or labeling of the data is very costly, especially some domains where really domain experts are required. So for them, it's many times it is required that group the data. Grouping means that suppose as an example, I can show here that some data points are there. So we have to group it. So what is the grouping criteria? That the data point which are closer, they will be put into a single group. And data points who are in the different distance, then they will be put into different clusters. So here, for this perspective, you can see that if you are going for cluster, it is expected that this red, that is right side, they will have one cluster and this will be another cluster. So here the things need to be minded there. Clustering. So the thing is that clustering, there is no control of the labeling. So what is the basis of clustering? That thing is not known. Suppose someone is trying to cluster among the students. So it can be done based on the gender. It can be done based on the which kind of play he or she is doing. Like some are playing cricket, some are playing badminton, or it may be that cluster based on their merit, etc. There are several criteria will be there. But in case of a clustering algorithm, what is the criteria they are maintaining to group their data? It's not known. You cannot impose those things into the clustering algorithm. So you have to cluster the data. After that, you can, looking at the cluster properties, you can decide that on the what is the basis for cluster those data. Cluster is many purposes. Those things are important to identify the number of different patterns are available in the data. That is, but suppose you are analyzing and finding that what are the different types of customers are there who are purchasing from your site, that is from Amazon. They are maybe grouping the customers or grouping who are the vendor, who are vending, who are selling their products to the customers, etc., etc. So this goal of clustering is to find this underlying pattern, the similarity among the data, those things, and group them. And another part is that unsupervised learning is that dimensionality reduction. Dimensionality reduction means suppose we want to build a prediction model. So we are telling about X and Y. X means the available data and Y is what is its predicted output. Or maybe clustering only X is there. So X might be high dimensional. It might have 2 dimensions, 1 dimension, 2 dimension, 5 dimension, 50 dimension, 5,000 dimension, 50 dimension, etc. Whatever it may be. So if you are dealing with these kinds of, suppose 50 dimensional data, so it will increase the computational burden. You know what will be the computation. So I am not going details about the clustering or the multi-layer perceptual algorithm. But if you feel that you can, for the timing, assume that if the dimensionality is too high, then this computational complexity will be highly increased. First thing. Second thing is that for those doing those kinds of learning tasks, all features may not be equally important. So, as an example, what I can say that assume that all features are not important for all, or may not be useful for all tasks. So you need to reduce the features. So that is called dimensionality reduction. So this is a unsupervised dimensionality reduction. It can be done. Mainly it can be done as well as supervised also be done. So dimensionality reduction, it reduces discard the unimportant features based on some criteria and reduce the computational complexity for your prediction models. That's the goal of this. So these are the main goal of this unsupervised learning tasks. Now, the important thing is that designing a machine learning prediction system, what you have to do. So here, the machine learning system designing, the important part is database preparation. Why database preparation? Because here we are going for learning from experience, or we have previous experiences or data. So database preparation means collect the data from the application, for this application from the ground, and then discard the poor quality data, that is data cleaning, and then level the good quality data with the expert. That is database preparations. So data collection, data leveling, and data selection. Those are the part of data preparations. Now, while you will be putting into a machine learning algorithm, first thing you have to do that feature extraction. Why feature extraction? So I am telling that I want to classify images. So how I put this image into a machine learning algorithm? Here, what I have discussed previously, that a machine learning model can take some real valued input in the form of x vector. So you have some vector, that is x, that which every column of which represents a feature for certain attribute. So you have to find these features. So for image, how from an image, how you can get a feature. That's the issue. You have to think on that. Suppose you want to translate or predict that what will be next word. Suppose you are typing some email, you are finding that some text coming and suggesting some things. So for these kinds of model building, from that text, how you can convert it into a data vector, that is vector of real values. Those things are done during feature extraction. So this needs an handcrafted engineering effort for this feature extraction. Then the next thing is that feature selection. So these things may be considered or may not be considered, because some algorithms already have inbuilt feature selection mechanism and some algorithms do not have. So after feature extraction, the next task is to discuss unimportant features or transform the feature vector into low dimension. And then you will build the model. So I give some examples, what are the machine learning models are there. And then send this model for deployment. This is the pathways for designing a machine learning prediction system. Now, the important question is that, will the trained machine learning model predict perfectly? Which algorithm do I choose? Because I am saying that several algorithms are there. For the same things, you can apply KNN, you can apply support vector machine, you can apply logistic regression. So which ML algorithm I will choose? Another thing is that, will the trained machine learning model predict perfectly? So I was start my talk with that the data structure, what we are reading, that is the computational speed up, the algorithm which are available to us, their performance simulation criteria was how fast they are doing, and we are looking for the asymptotic complexity and how fast they are doing. But in case of machine learning model, another factor is coming, that how good your model is in predicting the future or the test data. And which ML model do I choose? So one thing is that how good in prediction, as well as how complex is it. Based on that, you have to choose. So I am going to little bit details that how you can measure the performance matrices. So suppose regression problem is there. So as I discussed that what are the statistical measures for the regression? So you can go for mean absolute error. Suppose your actual data points value is y1, but it is predicted as y1 dash. You don't know that what would be the price of the petrol in 2030, but you have created a regression model, and now you have the predict that what will be the price for the petrol in 2030, and in 2030 you go and see that what is the actual price, that is y1. That is the price of the y1. While you will reaching, you can know that, and you can find the difference between these two, and it is called Mills absolute error. So for the whole number of data points for which you are predicting, you can compute these things, and you can say this is the mean absolute error or mean square error, and this represents how good your prediction model is. Mean absolute error, it is saying error, that means less means better. Mean square error, that is less means better. And how we go for classifications, algorithms, performance measurements. So suppose your data are given, a number of data are there for which you make predictions. So its class levels, actuals and predictions are given, actual and predicted are given. So you see that for some data points that one was the ground truth or actual and predicted also one, and here we are saying that zeros are also there. That means they are correctly predicted and others are not. So one terminology is there, or thing is used here. It's called confusion matrix. That is, it is a representation that how many positive data is predicted as positive, that is true positive, and how many positive data is predicted as negative, that is called false negative. How many negative data is predicted as positive, that is false positive, and how many negative data is predicted as negative, that is true negative. So here true positive is this 1, that is 3. Means others are also there, these are not shown here. So what it is, we cannot count actually, but looking at that, we see that green are represent is true positive and yellows are true negative. And false negative, that means falsely become negative. So 1, 0, these are false negative. So you can have this matrix and called confusion matrix, and several matrices or evaluation performance matrices can be used for computing the performance. One is this accuracy, that is true positive, that is sum of the diagonals by all four, sum of all fours. Here P means number of positive data and N means number of negative data. That is, here total number of data is N. So don't confuse with N and this N and this N. This is accuracy. And error is false positive or false negative by number of P plus N. So accuracy plus error, it would be 1. And precision or positive predictive value, that is true positive by true positive plus false positive. So I'm not going to details about this because until these are not discussed in with much time, so you cannot remember them. But as a formulas, you can see that accuracy, precision, recall, you can think that those are the mostly widely used performance matrices used for that. So if someone need to know that what is the importance or know more about any of the matrices, I will discuss. Otherwise, I am moving to the next part. So if you want to ask, so ask me in the question and answering sessions. So now I am moving. Now, experimental design. So in case of machine learning, so one important thing is that experimental design. That is how you choose which kind of ML algorithm will you be using. So you have to design a common experimental setup and you have to apply different prediction models applicable, and among them you have to choose the best performing model. So what it is, suppose this is the training data. What you have to do, you have to split into training, validation and test data into 3 parts. So there is no overlapping among this data. Then using the training data, you learn, that is W's for the multi-layer perception or logistic regression, support vector machines, the support vectors, etc. And use hyperparameter, because every algorithm has several hyperparameters. So those things are not discussed. That what are hyperparameters? That is parameters required to train a model, and parameters which are learned, that are the models hyperparameters, and hyperparameters means which are used to training purposes. So for the time being, assume that something are there to train the model while you will be building these mathematical models, that is prediction of W1, W2, prediction or maybe guessing. This time some user inputs are required, they are called hyperparameters. So hyperparameter selection is done with the validation data, and finally this test data, based on the test data, the ML model's performance is computed. So training and validation data are used in training phase. So validation data is used for hyperparameter selections, training data is used for this model building, and when this model is built, the test data is used for performance evaluation. So for different algorithm, for the same split, if you apply these things, you can get the performance for different kinds of models, and based on that, you can decide that which model is better, and you can take and recommend these models. So this is not the end. So there are several ways for experimental design. So here I am talking about the most or widely used things. So usually what would be the DV split, training, validation and test? This depends on the designer of the algorithms or and the number of available data sets. So other thing is that independent holdout test data. So another times it is recommended that you build your model with this data set and keep one held out data set in reserve and check the performance, because here you are changing your hyperparameters and etc., and based on that you are finding the performance, and held out data set will be in the client side, and while you will sending to them, they will check the performance, evaluate the performance, and based on that they will decide that which algorithms they are needing. Another is the k-fold cross-validation method. Here what it is done, in many times that good amount of data are not available. In that time the data, sorry, hello, something are you talking? Something is, okay. Can I continue or?
Sir, you please continue, sir.
Okay, thank you. K-fold cross-validation method. So here the thing is that many times the data may not be that much amount. So that can you please, some noise is coming. Okay. Okay, thank you. So in the previously I was saying that how 10 test validation split are used for performance evaluation or comparing different ML algorithms. So another approach is the k-fold cross-validation. So when you have a good amount of data, in that case these kinds of 3 splits you can do. But in some scenario you may not have that much data. So what you are doing, that here the data set is divided into k different folds. That is divided into k parts. There are non-overlapping parts. So no data will be same in the two. No data will be in the two folds, two different folds. So it is called k-fold division. After that, k minus 1 fold data are considered for training, and the rest kth fold is used as a test data. So training, every time k minus 1 fold are used for training, and the rest fold is used for testing. So you have k number of test data and k number of trained data by while you are dividing like that. Then take the performance, average performance of this division of the data, and based on that decide which one is your best model. And another approach is that leave one out cross validation method. This is a special part of k-fold cross validations. So when you have more or less number of data, so here k-fold, that is will be n-fold. That is, if you have n number of data, then you are using n minus 1 number of data for training and the rest data as a testing. That is, leave one out cross validation method means n-fold cross validation if you have n number of data like that. So up to now, I am giving an idea about this machine learning field. Now I will conclude. So it is important for doing this prediction task. So many things you know that machine learning is applied, what are the field, etc., etc. So I also discussed some areas, and so it is employed for prediction tasks because there are nothing else to do except machine learning. And now the recent progress of the machine learning shows that they are quite capable of making good predictions in certain fields. I am not claiming that all fields machine learning is predicted up to the mark level. Next thing is that data acquisition is challenging, but prediction performance depends on the amount of data available. So for the machine learning algorithm developer, the first and foremost task is to data acquisition, data cleaning, data labeling, etc., which is challenging, and you have to do that. Next thing is that feature representation is an important. So here I was telling that from the text, how you will convert into the feature vector. From the image, how you will convert into a feature vector. From the ECG signal, how will you convert it into a feature vector. Those things are there, so this needs some engineering effort. And another thing I was conclude here that several ML models are not human interpretable. So I think that you already among this, when I am telling that not human interpretable, you find out that which model is interpretable. So see decision tree. Here the way human are taking decision, only this model is human interpretable. Others are suppose some feature vector or features is there, you are multiplying with something. Then why you are multiplying with that? What is the meaning for that? It's not known to you. So those are not interpretable. So it's some books I am showing. So interested reader may go through these books. Any questions? So that's all. So if anyone want to interact and have some questions, so can ask me.
Participants, if you have any questions directly, you can unmute and ask, or you can write in the chat box. If you have any questions, you can ask. Okay, I think there are no questions. Thank you, sir. Thank you for this detailed, informative lecture. Now it's my privilege to introduce our second speaker, Dr. Deep Shubro Guhoroy. Dr. Deep Shubro Guhoroy is currently working as Assistant Professor Senior Grade of School of Computer Science and Engineering at Vellore Institute of Technology, Vellore, India. Prior to that, he has completed his second postdoc from Indian Institute of Science, Bangalore, as an institutional IOE postdoctoral research fellow. He has completed his first postdoctoral research at the Mobile and Cloud Lab of the Institute of Computer Science at the University of Tartu, Estonia, Europe, in Radon H 2020 project in the collaboration with Imperial College of London, UK. He was a corporate trainer of Microsoft Australia and BSc Institute, Kolkata. He was a faculty of Department of Information Technology at the Maulana Abul Kalam Azad University of Technology, West Bengal, India. He did his PhD and MTech from Maulana Abul Kalam Azad University of Technology, West Bengal, India. His current research interests include mobile cloud computing, IoT architecture, IoT security, blockchain customization, serverless computing, and many more. He has published 13 highly reputed ACI International Journal papers and 18 international conference papers and 7 book chapters in a total of 40 publications. He has received the International Research Leadership Award as Best Researcher of the Year on the Internet of Things 2020 by the World Research Council and other national awards. He is an associate editor of IET Software Journal and lead guest editor of SI in Elsevier IoT Journal, Elsevier Computer Communications, and many more. So let's welcome our second speaker, Dr. Deep Shubhru Guhoroy.
Thank you, Dr. Anindita Rai Chaudhary, for this brief introduction. So, first of all, thanks for this invitation. And my voice is a bit down due to I am suffering from cough and cold, and that is why please feel free to interrupt during the talk. And if you can't able to get my voice or able to understand the pronunciations or whatever it may be, so feel free to interrupt, no problem for that. And for bandwidth related issues, I am just switching off the video so that it can be moved smoothly. So let's proceed. Hello, am I audible?
Yes, you are audible.
Yeah. I'm trying to present, so that time it's got disconnected. Let me try one more time. Yes, wait. Please, anyone can confirm my screen is visible or not?
Yes, it's visible.
Okay. Okay. Now it's visible? It's not. Yes.
Now it's visible.
Okay, fine. So I have give a small title it in a different manner, that a zip with cloud computing technologies. Because why? Here I am going to discuss several cloud computing technologies and the upcoming technologies. What we are working on and what we are going to be working on it. So based on that, we are zipping the concept. So that is why I have titled in a different manner, like a zip with cloud computing technologies. And for my introduction, it's already done. So let's go for the outline. Okay. So prior to go to the outline for today's discussion, let's know about the how cloud computing came to the picture. So mostly we are using classical computing. Like suppose we have to run any kind of applications. For that, what we have to do, we have to buy and own some hardware, system software, application. Then in that top of that hardware, we have to install that system software, and top of that system software, we have to install the application software and configure it. So after configuring that, we have to test, verify, manage, then we can use it. So for that, you can think what are the things we have to buy and own. So it is a costly computing. That means classical costly computing. So traveling to that classical costly computing, we are moved to cloud computing. Why? Because here you don't have to purchase any kind of hardware, any kind of system software. System software means like operating system and all, any kind of application software. So whenever, wherever, whatever you want, you have to just subscribe and use and pay as per use basis. So it is just making your use very easy and cheap. So I think someone is not muted. So please mute, or if any question, please ask. Because I am in a single screen, I can see the next screen is not muted. Okay. So the outline for today: computer utilities, then cloud computing and the related paradigms, then market-oriented cloud architecture, then Aneka, a cloud application platform, then new computing paradigms for IoT applications, then summary and the future directions. So first, go for the first outline. So this is a wave of computing paradigms. You can see in the lower side, it is 1960 to 2020 and onwards. That means towards 2030. How that computing changes. First, we are using the mainframe, then mini computer, then client server architecture. Hope you all know about that. Then we converted it to the web-based application. Then from 2010 onwards, cloud computing came to the picture, and after that, cloud, the backbone uses as cloud, and top of it, we are using the various kind of IoT environments and the fog computing environments. So I am coming what are those in detail. Next, why we are doing this kind of computation. So already the previous speaker has said about machine learning, and there the main thing is the data, as he said, and you all know that based on that data and data set, we are going to predict something, right? So the data is a very important thing, and how you are preparing that data and analyzing that data, that is also very important. So nowadays it's a data driven world. Why? We are using Facebook, we are using Instagram, we are using WhatsApp, LinkedIn for professional uses. We are just posting with our free internet, or you have purchased Jio internet and all, but we are not thinking where this data is going for and how this data is going to be stored, right? And how it is going to be computed. So there is a big question that big data for big science. So why it is called big? So you can think and you will find many answers in many forums and all, but the main thing is that why big? Suppose you can think you have two brothers, along with you have two more brothers or two more sisters, or mix and mix match of brother and sisters. That means A, B, C. A is the youngest one and C is the oldest one. So for you, suppose you are the A. So for you, you are the youngest one. That means B and C, your brothers, are older than you. That means they are the big brothers for you, right? That means what is big and what is big data? If it is big for you, that means some piece of data is big for your computational device, that is big for that device, right? What I am trying to say, suppose your mobile can able to compute 1 GB of data at a time, and you are forcing it to do a computation with 2 GB of data. That means 1 more GB of load to that computational devices. That means that data is big data for that device. But for a more resourceful device, it is not big. So that means it's a very comparative and related feature. What is big and what is big science? So based on that, you can easily tell big data depends on multiple V's that you all know: variety, volume, blah blah blah. But why it is big? Based on the resource of a particular device. If it can be computed by that device, then it is not big for it. If it can't be done, then it is big for it. So for that, why I am discussing this, for this kind of scenario, we can take the help of the cloud instances, right? So that instance can give you a immediate support, so that you can compute that additional part together. So how this huge data is getting generated nowadays? How? Due to this Internet of Things. So Internet of Things means everywhere we are just attaching some sensors, and that sensors sensing data every second and sending it to the next level for storing. I will come to the picture how it works. So first, for now, you just think sensor are there, it's sensing and it is forwarding the data for the next level. That means for everywhere, you can check from my pictures of my presentation, we are just fetching some data and trying to store it, right? So it is generating huge volume of data, which it's making the computation more tough and tough. Okay, so how IoT application and cloud computing and the internet framework works. So let's explain that. So left hand side, I have mentioned the IoT devices. Then the next section, how that IoT devices are working for the smart systems and the so on. So you can check in the left hand side, IoT devices for smart healthcare, IoT devices for smart home, IoT devices for smart city, IoT devices for smart farming and smart factory. So using this smart system, we can say, sorry, the entire framework is getting smart. So there is 4 points I have mentioned, 1, 2, 3, 4. You can see for the first one, we are directly communicating with the last one. That means cloud data center. Okay, that can be one option. Smart system can directly communicate with the cloud data center and store. The next, we can communicate to the next level, that is edge network level, and if it can be done or resolved in that level, it's okay. Otherwise, we can forward it to the next level, that is core network resources. If it is not done over there, then we can forward it to the next cloud data centers. So in our second example, we have taken that we can able to solve in the edge level. In the third case, we have made it plus plus. That means first, second, third, all of the levels. And the fourth case also edge network resources, core network resources, and the cloud data center resources. This is the introductory part. I will again explain this same picture at the end, so that it can be more easier for you to understand. So next, I am telling you so many buzzword: fog, edge, cloud, IoT. So what it actually works and what are the difference between that? It's very important, right? So let's came from top to down. So first, cloud computing. There is some computers, and when we are using those computing devices, if we need any kind of help, we are going to the cloud data center. We are taking help from that cloud service providers. Next is fog computing. That means cloud and you, in between there is some core, another network that can also able to compute with the different more resourceful devices, so that you can forward your query and your requirement to the next level, and if it is getting solved by that level coming to you, or that fog can take the help of that the next level of the cloud. And the edge computing, see, in that edge computing there is no part of cloud. We are using our own computing resources, going to our next level, that is edge, and edge is solving our issues and going back to us, that is edge computing. And edge, we are using the more powerful resources in the edge level and pushing our small queries to that edge level so that it can be solved. Otherwise we have to take the another architecture. Next came to the picture is mobile cloud computing. So mobile devices are there, it is requesting to the cloud and getting output from that cloud. And another more important thing is mobile edge computing. That means mobile and cloud computing, in between we are using the edge servers as well. That means mobile devices are trying to compute, if not then going to edge. This is edge computing. If edge is also can't able to help, then it is going for the cloud services and coming back. So cloud computing, fog computing, edge computing, mobile cloud computing, and mobile edge computing. So these are the basic architectural difference and the basic difference of this kind of technologies. So this is the basic technological explanations. So next came to the main things, that is subscription oriented cloud services. That means whenever we are using, suppose Hotstar, Netflix, Amazon Prime, what we are doing, we are giving some yearly or monthly subscription charges and getting those videos and the web series like that. So previously what we have to do, we have to download or we have to store the movie into your laptop or desktop. Then you have to install a movie player, so that whatever the file you have downloaded, that file can be played by that player. It may be VLC, it may be codec, it may be media, any kind of media player. Then you can able to play and you can able to see that. Okay, nowadays with the help of internet and this kind of subscription, or may not be subscription, without subscription also you can see, but not all. So what you can see, you don't have to download, you don't have to think about how much big it is. So only you have to subscribe and you have to pay for that, and you have to pay your internet bill. Using paying that internet bill and using installing that only a small weightage software in online, you can able to see those videos over net. So like that, a subscription oriented model works. Same in case of cloud services. If you want hardware based services, that means you need more RAM support for computation, that you can get. If you want application based services, that means I want to use MATLAB, I want to use any other costly software like Oracle, and for IBM DB or something like that. So you can take those kind of supports. So you, whatever you are using, based on that you have to pay. That means application based support you can get, hardware based support you can get, storage based support you can get. So from this architecture you can see it's a very clumsy one. So just take a look from left to right. Sorry, right to left. So there is public clouds. That means you can access those clouds from anywhere. Suppose you think about AWS, Google, GCP, or IBM Watson. So what they are giving, they are providing many as kind of services to you. So what you have to do, you have to just create one account like Facebook, Instagram, and LinkedIn, and you have to use those services. You have to select from that list, and you have to use and pay for it. Okay. So what I have explained, so these are the cloud service models. What are those? Software as a service, platform as a service, infrastructure as a service. So what is infrastructure as a service? Infrastructure as a service means you want 16 CPU, that means processors for your computation. So you can take those kind of things. So you have to create one instance in your cloud platform. Instance means it's a virtual machine over internet where you can choose how much CPU you want, how much RAM you want, how much hard disk you want. That must be SSD or normal hard disk. You can choose like that. You can create your own machine, or you can create your own server, and you can log in from your machine to that remote machine and you can work. And next is platform as a service. That means suppose you want to build some application, but you don't want to use, suppose you want to build an mobile application, but you don't want to use Android Studio installed into your system, right? For this kind of scenario, you can use the cloud services. There are already some instances running with installed those kind of version. Just you have to pay and use. And next is software as a service. I have already explained you that suppose you want to use Oracle, MATLAB, this kind of things, just choose, pay and use. Nowadays, there is another service. It's a upgraded technology. It's called FAS. That means I have not mentioned here because it's a high conceptual things. It's FAS, FAAS. That means function as a service. So you can call it as serverless computing. That means some ready-made function libraries are already there. Based on your requirement, you are choosing those functions, preparing your template, and you are running that template top of that cloud. And you don't have to think why it is serverless. You don't have to think where the server is and where the physical server is located and how it is working, what is the IP address of the it. You don't have to think about it. Everything will be taken care by the service provider. You just have to pay and use. That is called FAS, function as a service. Next, that are the cloud service model, and the next is cloud deployment model. So here you can see there is three classical cloud deployment models. One is public, one is private, one is hybrid. So from the picture you can see someone is giving lecture in a public. So now I am giving lecture, more than one person is listening. I hope you are listening because it's a post-lunch session. I know post-lunch session is not more interesting, and I am trying to make more pictorial representation so that it can be more interesting to see, so that we are not getting sleepy. So like that, I am delivering something to more than one person. That means I am delivering to the public, maybe public of 39%. That means also public, and you all are listening. So like public cloud what providing services to all. Those who want to subscribe or listen, they can listen or take that services. Why I am telling you listen? Suppose you are logged in into this session, but you are watching a movie into your phone using your earbuds. That means Bluetooth earbuds. So your participation is recorded and you are getting a certificate out of it, but you are not actually getting that. That means public cloud providers is providing services to all, but not everyone is taking those services, right? But it is available for all. Those who are required for that services, they are going for it and taking it. And next one is private cloud. That means one-to-one. That means for your institution, you can create this kind of own private cloud environment where only your institution or organization can be benefited. So whatever the services you want, you can ask to the system admin of that cloud. They can provide you the credential you can use. For that, you don't have to pay because it's your private, right? So whatever the services will be listed over there, you can get. That is public cloud. And the hybrid cloud is a mix box of it. Suppose I have a machine, I am computing something, I am getting stuck, I am taking my organization help from the private cloud service, and then also it is not resolved, then I am requesting to the organization take the service from the cloud. That means I am taking the service of private as well as public. With the combination of that, I am taking the service from the both of the cloud service providers. That means private and public. So you can choose only public, you can choose only private, you can choose hybrid as well. So these are the three cloud deployment models. Now, cloud-based applications. So nowadays, e-commerce, after COVID attack, e-commerce and these online things are getting a boom in the market, so that they can get very many things over internet. So for that, storing purposes, computing purposes, you want the cloud services. And to run your cloud applications or your web application on top of that cloud, or you can create your cloud-based application where you don't have to think about anything. Everything will be taken care by the cloud service provider. So nowadays you can see from the pictures, Google, Facebook, Windows, Twitter, Dropbox, and many more, they are actually using this to make the cost effective computing. So you can check how e-commerce and social media email operations are getting change in 1 year. This is a record of 2018 and 19. It's bit back, and after 19 it's become more and more. So from here you can check how much posts are done in only 60 seconds. That means in 1 minute, how much post is done in Facebook, in Netflix, in Google, YouTube, and Instagram. So nowadays it's more and more, and many other applications came to the picture. So it is a very good statistics. From that I have taken this, but nowadays I have not found the updated one. If I found, then I will update this. Next, we are talking about cloud computing. Cloud computing we can do this and that and that. So everything has some challenges. That means problems. So how those problems came to the picture and how we can solve those problems, right? So here we are doing everything in a logical manner, in a virtual manner. So you can't able to touch. That means physical touch is not there. So how this virtualization came to the picture and how the virtualization can be done, it is a problem. So there is another segment, the problem of security, privacy, trust, and the legal and regulatory. I am sharing my all of the codes and data with the cloud service provider. Is it secure? So what are the regulations we have to sign with the cloud service provider and the users? And I am storing my confidential data in cloud. Is it trustworthy? So how much trustworthy it is? This is one segment of challenges. The another segment of challenges is how much pricing. So we are using those resources. For that resources, how much pricing will be there? How much bill I have to give? For that bill, I have to add the credit card. Is it safe? And it will be auto deducted from my credit card. And they are telling some bill and taking more money. So this kind of question came into your picture, and you can face this kind of challenges to solve that. So they are, and then came QoS and service level agreement SLA came to the picture as challenges. QoS means there is many QoS parameters like availability, reliability, and security, and many more. So I am using one server. So is it available 24/7? How much time will be taken to switch from one network to another network? What level of service that service provider is providing to us? This can be also problem. Then provision on demand. Wherever I will want, they are telling me they will provide the service. Is this kind of requirements always be available? Always they can able to provide that on demand service in dynamic runtime. This is also a challenge. And how they will manage the utility and the risk. Then how scalability is. How can we scale it up and scale it down like a rubber band as per our requirement? How reliable those instances are. Then energy efficiency. We are using those instances, how much energy it is taking, and how the programming environment and the application development environment and the software complexity issues can be resolved. So there are various open challenges for cloud computing are there, and many researchers are dealing with that and solving with their that problems with their solution, and they are really helpful for the industry nowadays. So for the electricity consumption, left hand side you can check. I have mentioned US, China, Russia, Japan electricity consumption, total annual consumption. You can check cloud computing only taking the electricity consumption in global level more than India. So, and next 2030, it is going more up and up. That means as we are using more and more cloud services, they are introducing more and more servers, and those servers are required power, electricity, and it is 24/7 running. So based on the statistics of international statistics from USA, it's on global electricity uses communication technology trends journal, they have introduced that after US, China, Russia, Japan, cloud computing is taking the 5th highest electricity consumption in the entire globe. So you can see there is a data center and it is consuming power how much, and the rates are the for the storage, 50% for storage, and for 34% for hello okay 34% for that rooms AC, and 7% for network. These are the most highest ones. You can see that mostly 91% it's already taken care by these three, and rest are the conversion and lighting. So data centers are taking so much electricity consumption. So based on that, it came to a alarming position. We are getting those services, but our environment getting affected. It's a 5th largest one. Then how market-oriented cloud architecture works. So from just take from top to bottom from the picture. So see, top of the level there is the users. Users are requesting to the SLA resource allocator. That means service level agreement resource allocator. So what they are doing, they are just doing an agreement with the users based on the pricing, VM monitor, and the accounting. For as per the requirement of the user, from the VM machine pools, they are just allocating VM to the users. And these VMs are nothing but a piece of a small piece of a chunk of a huge server, that means a physical machine. That means there is some physical machine. Top of that physical machine, we are creating lots of VM virtual machines, and based on the requirement, we are providing those virtual machines to the users. Next, same picture with multi-cloud. You can check when users are user listing is going more and more. So we are taking multi-cloud services. Multi-cloud means sometimes Google, Amazon, IBM, and ABC, other service provider, they have their own physical machines, but user wants to use AWS and Google together. Some of the work will be done in the Google server, some of the work will be done in the AWS server, and that can be merged. That is called cloud to expanded. So expanded cloud is nothing but multi-cloud, where we are using multiple cloud servers infrastructure together. Then when we are using this kind of architecture, we can say that using those architecture, we are going to create some cloud-based applications. So, as I am a corporate trainer of Manjarasoft, Aneka is a product of Manjarasoft. What is that? So you all know about Android SDK, right? Software Development Kit. So this is one kind of software development kit containing various APIs, ready-made APIs, and programming model and tools in that SDK, so that you can create your own cloud application without thinking about anything. So how it works? Sorry. So Aneka is the world's first platform supporting multiple cloud programming models. What are the programming models? Thread, task, and MapReduce. That means, suppose you want to create one application where in that application you want to split your task into multiple small piece of task, that means multiple threads, and each thread will be computed in their own choice, machine, and after that, when the splitting computation done, it will be again merged and delivered. That means divide and conquer. So first it will be splitted out, then again it will be merged. And how I am coming to the picture, and it will be done in the runtime, and you can use the multiple infrastructure. You can use Aneka in your private cloud, you can use Aneka in public cloud, you can use Aneka in your own machine, but you have to using those software development kit, you can use the APIs. Based using API, you can write your own code and you can run your own cloud-based application top of your machine, private cloud and the public cloud as well. So how Aneka applications work? Suppose this is the infrastructure and the last level. It may be data center, it may be your cluster, it may be your own PC, it may be public cloud. Top of that, you will install Aneka package. See, the Aneka package is installed. Now you will get this platform where you can do your SLA and QoS adjustment. You can use user management. You can schedule and execution your task. You can monitor your task. You can manage your application. You can do the dynamic provisioning. That means wherever you want, you can scale up your resources and scale down on the fly based on the models you are using. So suppose you are creating some application, you can create top of that Aneka so that you can get all of these benefits of that platform as a service. Then it will be deployed into the infrastructure like data center, clusters, PCs, and public clouds. Suppose he is the inventor of this Aneka software, or you can say platform. So here it is an image processing based application. So this image will be blurred, and then it will be, suppose we have to apply some image processing algorithm to this application, but we want to do in cloud dynamic management task. That means we don't want to do it together, we want to split it and work with the cloud resources. Let's see how Aneka works. So it will be splitted into 9 tasks. Then these tasks will be go to the Aneka threads, and then it will be go to the Aneka workers, then it will be processed and go back to the Aneka manager application, and again it will be merged and it becomes the changed version of it. So like this thread model of Aneka works in a dynamic environment. This is only a application to emboss the picture. So this is only one, you can do many things. This is a built-in applications. So it's a private cloud deployment mode. You can check here, workstation, cluster, desktop machines are there, and top of that master node and worker node can be created and used using Eucalyptus system. And it's a public deployment. Same Aneka, you can deploy the master node into the Amazon EC2 instance and the slave node into the Amazon EC2 system. That means there is some slave nodes EC2 system will work as worker, and some nodes will work as a master, and you can trigger your Aneka cloud application platform in public cloud deployment mode. And you can use this hybrid mode as well. So in your machine you can use your master and the worker will be in your public, or the reverse one. The worker will be in your own machine and the management and the master will be in the public one. Then coming to the new computing paradigms like IoT adaptations. So nowadays already I have told you, you can see this is a map of world, and everywhere the sensors and the sensing devices are connected. As I have already told you that smart city, smart healthcare, smart industry, and how this IoT driven smart world can be triggered from left and right. Let's see, it's smart home can be done, smart healthcare in a smart city with smart retail, where the smart connected cars will be going, and that connected car will be controlled with the smart transportation system, and that will be managed with the logistic and supply chain control. And there will be some smart agricultural industry. That is why we have came to the picture of industry 4.0, where we can mine our own data for our data driven world and the smart grids. So here you can see it's a Rajiv Ranjan's paper in the IEEE Cloud Computing Journal. They have told that it's a IoT driven smart world where everything will be smart and the backbone of everything will be cloud. So IoT and the backbone is cloud working together to make the world smarter. So you can check the same picture I have explained at beginning. Why again that picture? So whatever that we have discussed in first, and now you can relate how IoT devices and the smart system and the networks with edge, core and data center works together to build IoT applications and the computing paradigms for the next generations of computing. So the next thing is the fog computing elements. It's a very basic conceptual picture. You can see left hand side IoT devices. Those IoT devices are connecting with the fog nodes as a gateway, and that node will be forwarded to the fog computational node section. There is 3 subsection of broker nodes and the general computing nodes and the repository nodes. What are those? Broker nodes only take the request and push it to the general computing nodes, and there are many Raspberry Pis, that means small computing devices, chip, and there, and using those cheap computers you are creating a cluster of computing in the fog nodes where you can solve the big problems with that small devices as they are working as a cluster. And for storing the entire thing goes for the repository nodes, and the broker nodes are directly connected with the cloud infrastructure as well. If in their list that these resources are not free, fog request came but fog devices are not free, that time it will just redirect the query to the cloud infrastructure and get the output from cloud and forward to the requested query part. So whatever this fog computing concept is, for if you want to do get this flavor, you can use the simulator as well. So there is an available open source simulator, it's named iFogSim, where you can do these steps what I am explaining. So there you can create imaginary IoT sensor, those sensor getting values. You can use fog devices, you can generate your data and data stream, you can monitor and predict performance, and you can do your create your own knowledge base. You can do resource provisioning and own scheduling, or whatever the scheduling algorithm already there, you can do that. You can do your own application models and IoT applications. So this is a simulator, is called iFogSim, where you can do fog and edge computing based simulation as per your requirement. And the last point is the summary, whatever we have discussed. So what we have discussed about cloud computing, visions and the reality, how cloud computing came to the picture, what are the service model of it, what are the deployment model of it, how the market oriented architecture works, how Aneka platform works, and how you can use those Aneka for building your application, then how the data is getting generated from IoT environment, and the new innovation steps, how it works. So there is one thing, the architecture for future generation cloud computing. So nowadays we are actually using this. So from here I have already told you that in the backbone we are actually using cloud computing. That means IaaS, PaaS, SaaS. That means infrastructure as a service, platform as a service, software as a service, the middle section. Okay, and you can check left hand side and right hand side, there is data centers are connected with the PaaS, that means platform as a service, and that cloud data center will connected with fog and the IoT environment, and those IoT sensors are directly communicating with the software as a service. Mobile devices are directly communicating with the software as a service layer and the user as well. In that software as a service, there are enterprise application, web application, scientific application, and many more. And those software are actually developed in the top of platform as a service, where the application deployment and delivery can be done, and the resource management. And this entire thing is actually running in the top of the hardware virtualization, containers, that means Dockers nowadays, or and the software defined networks, how the virtual machines, whatever we are creating, they are communicating between each other. It is defined with the software-defined network. So this is the architecture for future generation computing. So this is some my works, and I welcome you all to connect and collaborate with me for research and development. If there are any questions, comments, and suggestions, please ask. Thanks for your attention.
Participants, if you have any questions, you can write in the chat box, or you can directly ask the speaker. Just unmute yourself and ask the question if you have any question. Okay. I have a question, just an elementary question, that what is the basic difference between the function as a service and the software as a service? Because this term is a new one.
Right. Function as a service means, suppose software as a service means you are using, suppose the entire software is there. So some of the time we don't want the entire software. Like I am giving you one example. Suppose you want to move some data from Google Cloud to Amazon Cloud. Okay, so in Google, they are actually using blob storage. It is called Google Blob Storage. And in case of AWS, they are using S3 bucket. So Google and Amazon are actually using different kind of data structure and the different kind of network policies. So if you want to use both of these, suppose you want to move your data from S3 bucket to GCP blob storage. So there will be many harassment you have to face. But if you go for function as a service, that function library giving you how your function, that is called Lambda function in case of AWS, you can use one Lambda function where it is already written how you can connect with Google and AWS. You just have to insert your user ID and password and some credential. It will automatically move your data from Google to AWS. So here actually you are writing your own piece of code as a function with the help of the additional library function to move and work and get the service out of this cloud computing services what they are providing. So they have named as function as a service, the main under the head of serverless computing. So is it clear? It's a bit tricky thing because you are not actually using the entire software. You are just using a particular already written functions. So create your own template.
Actually, for students, I am asking that is it like importing Java packages over internet, like that sort of thing? That
So
only that portion will be imported, or
see there. Suppose you can open Paint, right? You can open Paint and drag and drop a circle and rectangle. You can do additional lines and you can draw your own image, right? Whatever you are thinking, like that, you can drag Google service, you can drag AWS service, and you can drag Lambda function, connect, and after clicking that Lambda function, it will give a already ready-made piece of code, and based on that you can edit. That means a template code they are providing to do varieties kind of work, and you will edit based on that, and you have to know some bit of Ansible scripting and how you are choosing the Lambda function based on that, and you can run it and it will work as a executable file, like you have written a software like that. So these kind of things. So it's a handy ready-made product for the users.
okay. Thank you for your lucid explanation and informative lecture. Thank you.
Okay, thank you. Bye all.
Bye. Now, I would like to request Dr. Anandarup Roy, HOD Computer Science, to give away the vote of thanks.
Thank you, madam. Thank you, Dr. Chaudhary. Am I audible?
Yes, sir.
Okay, that's great. That's great. So, good afternoon, everybody. On behalf of Sarojini Naidu College for Women, I, Anandarup Roy, take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this national webinar on a gentle introduction to machine learning and cloud computing. At the outset, I must mention our deep sense of appreciation for Dr. Anubik Pal for his introduction to machine learning and its importance. Well, what I understand that machine learning is no more a theory. Nowadays, it is applied to solve complex problems in different industries, ranging from healthcare to manufacturing, maybe. Okay, so machine learning, in that sense, machine learning can identify your disease from certain symptoms. And it is equally capable of automatically translating your message to some unknown foreign language. So this is the, whole area of machine learning where it is still evolving, right? So overall, this area seems quite promising in handling real-world problems. And of course, we'll be interested to follow recent developments in this area. And thanks again, Dr. Anubik Pal, for this wonderful introduction. It's really interesting. Well, further, we are grateful to Dr. Deep Shubhra Guha Roy for introducing cloud computing. We understand the importance of cloud for business growth. Focusing on environment issues, I think hosting business on cloud is more environment friendly and of course will reduce the carbon footprint. On the other hand, the cloud will help organizations to reduce hardwares in a cost-effective way. So the most interesting thing I found in this lecture is that the cloud offers a scalability that is to use as many or as few resources as you need. Why this feature is interesting to me is that because it opens the possibility of implementation of a very complex real-life problem, machine learning solution to a real-life problem in a cost-effective way. Okay, now using cloud computing, we can actually implement machine learning problems. We don't need to rely on standalone machines. Okay, so in that sense, his lecture was so interesting for me. I'm a machine learning researcher, but I really enjoyed the cloud computing lecture. So I think we should follow the developments in this area, in this cloud computing area. Well-respected speakers, we are really enlightened with your knowledge and your presence. I'd like to express my sincere gratitude to Dr. Anjan Sinha, President of Governing Body of the college, and our principal, Dr. Urmila Ukil, for their enthusiastic support. A special thanks to the organizing committee, the IQSE members, the teaching and non-teaching staffs for their constant support and coordination. Finally, our heartfelt thanks to our students for their active participation. Well, with these warm words, we move to the end of today's webinar. Once again, thank you very much. Goodbye and have a nice day.